Now, today my part is I would like to discuss about internal messaging of the Mule applications. VM component. Using VM component, we do internal messaging between Mule applications. It's called a virtual machine component. It stands for, but in simple terms, it is a messaging system between Mule applications. So usually it is a JMS queue that is called active queue or rabbit queue. Some implementations are there in the JMS. Okay, we use active queue, and I can share the rabbit queue also how to do rabbit queue. But that is an implementation. JMS we can use in between multiple, different kinds of applications, heterogeneous applications. Like maybe one application is running on a Python or Java or any other technology. So this application want to send a message to Mule application. So it will send message to the JMS queue, right? And Mule application can listen that message from the JMS queue.
Mule.
Okay. Mule application can able to listen that message from the JMS queue and process that message. So JMS is for multiple kinds of applications. Even we can put JMS between Mule applications also. Okay, it's not like, but JMS we can use different kinds of applications. JMS work as a broker between different kinds of applications. Where the VM component is purely between Mule applications only. Okay. VM is purely between Mule applications. And another thing is Mule applications run in a runtime, right? Server or runtime, right?
Yeah.
Okay. Suppose this is Mule runtime where we deploy all the Mule applications inside this runtime, right? This is Mule application. One Mule runtime is a server.
Okay.
Okay. Mule runtime is server where we deploy Mule applications. Even if we executing the Mule applications in Anypoint Studio, right? Anypoint Studio is embedded with the Mule runtime, Mule server. Anypoint Studio is embedded with the runtime. Yeah. So there we can deploy our Mule applications. That runtime is called embedded runtime Anypoint Studio. So embedded runtime is only for testing the applications. It's not for production grade server. Whatever application you develop in Anypoint Studio, that application you test inside this runtime. Okay. So, but Mule provides you the runtime, on-prem runtime. You can download it and you can deploy it. You can deploy applications on that runtime. If you are going for production, then you take license. But for learning purpose, you can download server and you can use it. So where we are actually between Qs and JMS, right? Qs VM component is the communication channel between the Mule applications that is running on the same runtime. So in this runtime, two applications got deployed, and I want to establish a communication between this app 1 and app 2 through VM component. app 1 can send a message to the VM,
Mm.
and app 2 can take out that message from the VM. So VM components as a broker between this app 1 and app. VM is one of the component. Okay, VM is not a mule runtime. Mule runtime is a place where we deploy mule applications server. Okay, VM actually, this entire mule is a Java application. Now, first of all, very first thing, why we need messaging? This app 1 is there, any application is there, app 1, and when app 1 want to send a message to app 2,
Yeah.
right, you can send directly a message to app 2, right? Then why we need to put a broker in between? You want your application should be more reliable. We're not sure our application will be running all the time. Maybe
Yeah.
applications were down for some time, some reasons. For
Yep.
example, application 2 is down, it is not responding. So application 1 is keep on sending the messages to application 2
Yeah.
without
Yeah.
aware of it is running, right? So we will lose the messages,
Mm.
right? Instead of that, if application 1 will send messages to some queue,
Mm.
right?
Yeah.
And messages will store inside the queue. And whenever the app 2 is up, it will take the message and process the messages. Right? In Mule, if you want to put this kind of queue between two Mule applications,
Mm.
and that two running inside the runtime where the Mule applications are running,
Yeah.
that is called a VM. There is one thing to publish a message to publish a message from application to VM. There is one component that publish a message. To listen a message from VM, there is a one component as a VM listener is there. Okay, we'll discuss about VM components. What
Okay.
are different components available? Now we are discussing about the concept called message channel.
Message
What
channel.
is
Okay.
the difference between the VM component and the
Mm.
JMS component?
Okay.
Okay, both are look same. Both functionality, the purpose is same.
Mm.
Okay, uh, it looks a little confusing between the VM component and JMS component.
Mm.
That you need to understand the difference between where we need to use VM and where we need to use JMS.
Okay.
Okay. So JMS is you go for JMS is a different server. Okay, RabbitMQ, ActiveMQ, there are different server.
Okay.
Yeah. For example, if you take RabbitMQ, we need to download the RabbitMQ and we need to start the RabbitMQ server. Okay. So inside RabbitMQ server, we need to create queues. Every queue has a name. For suppose we create a queue called Q1. And what we do is there is some application is running on .NET.
Okay.
So this guy will send a message to the Q1, and our new application can listen that message and process that message. Mule is running on the Mule runtime. This Mule application is running in the Mule runtime.
Okay.
So Rabbit MQ server is not part of the Mule runtime,
That's right.
right? This Mule server is different where this Mule application is running. And .NET application is running on some .NET server, some IAS server or something, .NET related server, separate server. So a client has a separate server, a Mule application has a separate server, a RabbitMQ has a separate server, right? So this
Mm.
may be sitting on different machine altogether, different geographical location, and our Mule application is sitting at geographical location. Really, there are geographically they are apart, right? So if you have such requirement, then we go for JMS. We are establishing communication between different platforms, right? This is the .NET platform, it is Mule platform, different technologies.
Wow.
right? They can talk to each other using the JMS,
Mm.
heterogeneous technologies. Whereas if come from Mule, VM component,
Mm.
VM component, actually there is something called JVM, Java Virtual Machine,
Mm.
okay, where all Java applications are are running. Mule runtime is also one of the Java application.
Okay.
So Mule's runtime or Mule server run inside the JVM. And inside the Mule applications, we deploy, so Mule server will deploy Mule applications.
Mm.
This is M1 and M2. This Mule application 1 and Mule application 2. Okay, Mule server hosts the Mule applications. Java virtual machine hosts the Mule server. And maybe some VM component also as part of the Java virtual machine, right?
Yeah.
So Mule application will send a message to this VM component,
Mm.
and this M2, this server Mule application 2 can take out the message from the VM component. So this is local to the Java virtual machine.
Yeah.
Okay. So this is little fast compared to JMS. VM is fast because it's local, right? It's not crossing the boundaries of your machine. This is
Yeah.
everything running on the same machine. Local VM is fast. When your requirement is very simple, you need to establish communication between the mule to mule or inside the flow to flow. We go for the VM. Okay, that improves performance of the application. Okay, right. When
Mm.
when this server, when two mule applications are running, one mule application is running on a one mule server, another mule application is running on other mule server, a different mule server. Mule application are running different mule server. Then if you want to establish a communication between these two applications, then we need to go for the JMS kind of stuff because they
TMS.
are not running on the same application, right? Same server.
Yeah. Yeah.
Okay. So where we need to go for VMware, if they are running on the same server, the application
Mm.
running on the same server, we go for the VM. The
Okay.
applications are running on different machines, we go for the JMS. Very simple for. There is one exception, I can tell you that when we deploy application to cloud, uh, there is, I'll tell you that one. As of now, just focus on this one. I can tell you the once we discuss this one at deployment, I'll tell you that one. How it behaves
Okay.
on cloud, how it behaves.
Okay.
JMS is actually a spec. Spec means it talks about how to, how a Java application
Mm.
talk to messaging system, to messaging server. This is the only spec where there is no implementation defined in this spec. Okay?
Okay.
Only a specification. Just just it talks about how your Java applications can send a message, can consume a message, can listen a message. All the things are defined. Only simple rules and regulations defined. There is no
Yeah.
implementation. So the companies like RabbitMQ
Yeah.
take this spec and develop the messaging server, right? That based on the JMS server.
Mm.
Now this is actual implementation part. People can put a message over here, can listen a message over there. And companies like RabbitMQ, so many companies are there. ActiveMQ. This is also based on JMS spec only. Take the JMS spec and develop the server.
Okay.
JBoss MQ. So different servers are there, all based on the JMS only. Okay, but these are actual runtimes, actual servers where they host the messages. They're all based on JMS only. You take the JMS spec and develop this standard. JMS is a standard.
Yeah.
Okay. JMS is a simple standard, which is not an implementation. Where is the ActiveMQ, RabbitMQ, JMS, these are all based on the JMS. They developed based on the JMS. With the help of JMS, we can need to send a message to these servers. Each server may running different, port numbers, different. If you configure that one, it will route to that server. VM is not a full-fledged messaging system. It provides very simple message. Just put a simple message to push a message to this queue and consumption of messages. Simple something like that. But we can't get acknowledgement, all the stuff. This VM is very simple messaging system. Okay. It doesn't have the advanced messaging features. And if your application needs advanced messaging features, need to go for the JVM, which are in JMS. So let me create one simple application. Find a new project. See, runtime. What is the runtime? Use server 4.0. This is the new runtime embedded inside this new Anypoint Studio.
That's right.
Okay. And my project is simple. So what I'm doing is I'm just publishing a message to the VM queue.
Okay.
So I'm configuring a listener. So HTTP client, I'm just get a message from HTTP client, and whatever message I got from the HTTP client, I will post that message to the VM.
Okay.
So I'm configuring the HTTP message. 8081 is okay. The default configuration fine. Path I'm giving as we can send something. Now, to search for VM on the component palette, you find 4 components: consume component, listen component, publish component, and publish consume component. Right? So to publish a message, we use the publish component.
Okay.
So if I put a publish component over here, what this component will do is we publish a message to the VM queue. So I'm configuring the publish component over here. Connector configuration. It tells about how Mule application is connecting to the VM queue. And here you need to give the queue names. What I'm doing is here, edit inline, and I need to tell the queue name to which queue we need to post the message. Yes, I'm just creating the queue name. Queue name I'm giving as VM1. Something, any name I can give, VM1.
Yeah. Okay.
And here the transient tells about transient means by default it is transient. Means for example, when the server is, when this application is executing, some reason the server crashes or down, we use that message. Okay, it's the same configuration. If you put this queue as persistent, what happens is it stores the message to some external storage like a file system. So even the server crashes, we can the messages will be remained in the file system. We can restore the messages. Okay, that's the configuration of transient and persistent. So we can tell how many messages to host. That is about the max outstanding messages. 0 means it can host a number of messages. There is no limit for that. Okay. So that is about the queue configuration. Queue name is VM1. So now this is the only connector configuration, means we just created a VM queue over here. All right. And next thing is what content we going to post to the VM queue. So now I am posting the payload, or else if you want to post some variables, you need to change that to the variable name, so that variable content will post to the queue. Now this correlation ID we will discuss what is it that is important part of correlation, how the messages got correlated. So I will tell you this one. First we go for simple thing, we just go for complicated thing. Okay. Next thing is a queue name, to which queue you want to publish, right? So I want to publish to the queue called VM1. That is what I created in the connector configuration. Queue name is VM1. So in the connector configuration, you can create multiple queues. For example, I'm creating one more queue as a VM2. I'm making this as a persistent configuration. Okay. So there are two queues I created, right? One is VM1 and VM2. And while sending the message, we need to tell out of VM1, VM2, to which queue we want to send. You can choose either VM1 or VM2. I want to send to VM1.
Okay.
Okay. Now what happens to publish like this? This publish component publish the message to the VM queue. That's it. It is a one way only. Okay, it won't expect any response from the VM server.
Okay.
Okay. If you put logger after this, what happens? I put logger. I'm just publishing the building the payload of the completing the payload. Just observe it here. Simply I'm deploying the application. So meanwhile, I can tell you one thing. Here you can see the three tabs, right? Message flow, global elements, and configuration XML. Three tabs, right? Message flow section. This is a graphical view of your Mule application.
Yep.
Okay. So graphically, you see the listener, publish component, and logger. And if you see the configuration XML, this is a source code view. The same, same application. If you do anything over here, add a new component, you delete a new component, that is got reflected over here. Okay. So now, as part of your Mule configuration, Mule applications, there are some configurations we use in multiple flows. This is one flow, right? You may have one Mule. This XML can have multiple flows. This is flow 1, and you can drag one more flow. This is flow 2, right? Flow 1 and flow 2. You have multiple flows. If your configuration used in multiple flows, the same configuration, what we can do is we can make it as a global configuration, and that global configuration is referred in multiple flows. Okay. See, what I'm doing is here, I'm creating one more flow. I am referring this one and some VM receive. Path, see, only path I changed. Okay, see, if you see, this is called VM send and this is VM receive, right? And counter configuration, see, the counter configuration is HTTP listener config, and here also the counter configuration is HTTP listener config. They are both referring to the same counter configuration, right? I am putting some logger over here, simply one logger. This is Now, these both flows are referring to the same configuration, same listener configuration, right? So that is a global element. See, global HTTP listener config is a global element, and that global element are referred in multiple flows. Okay. In sense, do one thing. Come to configuration XML, right? See here in the configuration XML, there is a tag called flow. It's a flow starting,
Yeah.
and this is called flow ending. Slash flow is flow ending. This segment, right? This
Yeah.
segment represents a flow. Okay, this is one flow, and there is one more flow starts over it. The two flows are there in this, right?
Okay.
Okay, so if you see, this is flow one, this is flow two, right? The same two
Yeah.
flows. So the configuration inside the flow starting and flow ending, that is called flow local configuration. See, this is called flow local inside the flow, simple flow, right? This is also local to this flow. But if the configuration is above all the flows and it is not inside a flow, see, this is not inside, not enclosed in any flow, and this configuration is also not enclosed in any flow. These two configurations are called global configurations. Okay, they are not local to any flow, right? And see, there is some component called HTTP listener. It referring configuration referring to something called HTTP listener config, right? This HTTP listener config is defined over here. HTTP listener config. Okay. So what this listener component is doing, it is referring the global configuration. See, the name matches over. The ref and the name should match. These two are matching means this is referring this global configuration. What's the global configuration? The host is a local host and port is 8081. Right? And the second flow also, the HTTP listener tag, that is also referring to HTTP global configuration, HTTP listener configuration, this one. Right? Means both flows, both listeners are pointing to the same host and same port. And what is the difference is, this is defined second, a path called VM receive, the second listener. This is a VM send. Okay, this should different. If you don't, if you differ, this is also same, you will get error. See, this is also global configuration. VM config is global configuration. Is not enclosed in any queue. It's any flow. This configuration is referred while publishing the message, right? See, VM publish is a component that publishing the message to the queue. VM : publish, and that there I can expand this one. See, VM publish. Queue name is VM12. This published in VM1 and reference here. Also abstract format. And yeah, in VM publish, the configuration ref is VM config. So where the VM config is defined, that is defined as a global configuration.
Okay.
Right. Even the second flow, what I can do is I can consume the message. In first flow, I publish the message, right? In second flow, what I do is I consume the message. For that, I am go to the VM and consume the message. For consuming the message also, I can refer to the same VM configuration. Publishing also, I'm configuring the same VM config. Consume the same VM config. I want to listen from a queue called VM. I publish to the VM1 queue. Right, publish to VM1 queue, and I'm consuming from the VM1 queue. Right. What is the basic difference between synchronous and asynchronous? Mule application, any kind of an application.
Mm.
I'm a client. I send a request to this application,
Mm.
and the same request, the same thread, I expect the response.
Yeah.
Okay, so maybe it's I wait for 30 seconds or something like that, and the same request, a request is sent, and I will expect the response.
Mm.
If I don't get the response, the client will time out. I will time out error.
Yeah.
Okay. So this is called synchronous call,
Okay.
right? So when the client expects the response immediately on the same call, it won't wait for long time. Okay. Whereas asynchronous work like this. Asynchronous client send a message request. And what is asynchronous? Where we do for asynchronous, there is on this request, it requires some approvals. Okay, for example, you are applying for a loan, and loan they won't approve you at that moment. They do some background checks and some credit checks,
Yeah.
and after that they will respond back. Okay, your loan is sanctioned, something like that. Okay, so for that, for long running process, we use the async system. For async system, what the client will do is, along with the request, he will send the callback URL. Callback URL.
Okay.
Yeah, along with the request, he send callback URL and tell that server, hey server, once you complete your process, send your response to the callback port.
Okay.
And it will send the response to the callback port. Then the client will pick up that response to the callback port. That is not happening in the single call. One call is for request, and the server get the callback URL. After processing, the response will send to the callback URL. Okay. Now these are two different calls, right? One call is for request and one call is response. This is asynchronous call, right? Isn't timeout. Asynchronous is it won't expect the response immediately also. So it won't wait for response from the server. Just send the message. That's it. One way only. It's only one way. It is one way, and this is one way. One way response, one way request, and one way response. Whereas it is two way. This is synchronous is always two way. Two way means request and response on one call. Okay. Request response messaging pattern. These are all called messaging patterns. In asynchronous call, it won't wait for response. There are two types of asynchronous calls are there. Okay, one thing is, see, as a client, I'm calling the server.
Yeah.
Server application or some server application. Okay. So I'm just sending a request. I won't wait for response, and just send a request, and I can do other activities also after this one. For example, there is something called send a request to some some queue, and next print that request to the file, and do some database call. Something is there like this is there. Okay. So what I can do, I can send a message to the system and continue my work with other components. I don't wait for the response. Okay, I want to block over here. Whereas a synchronous call, I block over here until I get the response from the server. I can't move forward. Okay. Once I get response only, I can move forward. That is called synchronous system. It's a synchronous means it blocks. It blocks until you get the response from the server. It blocks here itself. Whereas asynchronous, it just send a message to that server and keep moving and executing next components.
Yeah.
Okay. Now sometimes we'll get doubt. We send a request, right? how we can get the response back and where we can need to collect that response, right?
Mm.
Okay. So like I said, there are two ways to collect the response. Uh, one way is, no, it is not related to Mule. It's a general concept actually. Assume this is the client and this is server. And the client send a message, and the client also expecting a message, but not immediately. Okay. It knows
Yeah.
this is a long duration call. Server will take some time. After some time, the client will expect the response of this message, response of this request.
Yeah.
Okay. The two ways we can do asynchronous calls. One is polling manner, polling way. Polling way is something like there is some agreement between client and server.
Yeah.
So once the server processing this request, it will put in one place. Okay. Server take the request and process the request. After processing, it will put the response in a place.
Okay.
Okay. So the client keep on checking this place.
Okay.
Is the response arrived? Is the response arrived? Is the response arrived? It is some scheduled call is there.
Yeah.
Some scheduler keep on checking this place for the response. If the response is available, it picks that response and process that one.
Okay.
Okay. This is called polling manner, polling way. Okay. And
Got it.
second is the callback. In callback way, client won't check for response. While sending the request itself, it gives some path. Hey server, once you finish your processing, please send a response back to this path.
Yeah.
That path is given in the request itself.
Yeah.
So server process that request, and once you finish the processing, the response is sent back to the path the client is given. The client pick the response. So these two are the asynchronous ways of implementing the system. Okay, this is a bit a preferable manner compared to polling. A
Yeah.
callback is preferable because client need not check every time, right? Once you are passing, you get the response from the callback port. Okay, but see, this is one way, and sign client also server sending to client in different call. This is two-way call, right? Two different calls,
Yeah.
not in single call. Single call means single call that is synchronous. What the important takeaway in the today's session is about the source code. Okay, most of time we work on the graphical mode, but
Yeah.
it is equally important to have idea on the source code, how the source code is getting generated. When
Yep.
you add a new component, when you delete a new component, what is a global configuration, what is a local configuration, that idea is very important. Fortunately, and I'm running this application. I demonstrate and conclude the call. Okay, madam. There is some 8081 conflict in my machine, so I changed it to 8085. 8085 slash VM G post. I'm sending some content. Okay, this is the content I'm sending.
Okay.
This message I'm sending to the VM.
Mm.
So post it, and yeah, we send that message to the VM. And next, I want to get that message from the VM. So I'm choosing one more. P post 85. And what is the path to get that Queue is a flow that is fetching the message from the VM, right?
Yeah.
Get it? My spelling is wrong. Copy this one. Now try again. I got this message from. So one I post to the VM and other I retrieve from the VM. Getting that.
Okay.
Correct. So assume this is the flow.
Yeah.
And what I did is from the postman.
Mm.
From the postman. This is configured VM send, right?
Yeah.
Okay, so VM send, if you send VM send and post the message, publish, and
Yeah.
here somewhere VM queue is there. What VM queue? The queue name is VM1.
Yeah.
I told that VM1. So this will publish the message to the VM1.
Okay.
And it only one way. Just put the message and expand and execute the logger.
Okay.
In logger, I am printing the payload. Whatever a post message I posted that got printed over in the logger. I can show you the logger also,
Yeah.
right? And message is there in the VM now. So from the postman again, I'm invoking this listener using VM receive slash VM receive. The control comes to this listener. So this will go to consume. It calls the consume component. Consume will go and fix this message,
Yeah.
right? And use that message back to listener, and listener will go back and send to the postman, and I can that message got printed over in the postman console.